Welcome to my video on the triangle midsegment theorem. In this video we're going to define what a midsegment is, talk about the theorem that's involved, and do some examples. Pretty straightforward. Let's do this. The midsegment is sort of, kind of what it sounds like. It's a segment that is in the middle of a triangle. So in other words, it cuts through the midpoint of two sides, and a couple things are happening. Since this is congruent to this right here, those are letter D is obviously the midpoint, and over here same deal. You see two tick marks and two tick marks, so segment CE is the same length as segment EB, making point E the midpoint. In addition to that, it sets up a scenario where these two segments are parallel to each other. Alright, so then if we saw problems like this, we have these two angles corresponding, and therefore congruent. We have this angle, which is supplementary to angle A, because they are consecutive interior angles. We have all sorts of really cool stuff happening. But the theorem doesn't really say much about that. This is the key to the midsegment theorem. It says that the midsegment itself is half as big as this segment. So if this is 7, this is 14. If this is 20, then this is 10. And that's really it. There's also a midsegment of a trapezoid, which is a totally different video, totally different idea, but let's get into this. We'll do a couple examples. Here we go. Number one, I encourage you along the way when you watch my videos just to pause it and maybe draw the diagrams, try the problems yourselves. But here we have a midsegment. It's drawn. I know it's a midsegment because of these tick marks and these tick marks. It tells us that point L is the midpoint of segment BA, and it tells us that point N is the midsegment, or the midpoint of segment BC. Great. So we have a midsegment. Awesome. So it's parallel. The midsegment's parallel to segment AC, but I'm more concerned about what the length of segment AC is. If the midsegment's 60, then we know that the midsegment is half as big as the parallel side, so 60 is equal to 1/2 times x, or whatever you want to call it. Multiply both sides by 2, and we get 120 centimeters. Pretty straightforward. Number two, this time I'm going to give you the side here, segment AC, and ask you for the length of the midsegment. Well, same idea, same theorem. The midsegment is half as big as segment AC, so 1/2 times 108. So that's what, 54 centimeters, and it fits nicely, right? That should be half as big as the segment that's parallel to it. Number three. And if I'm going too fast, of course you pause and rewind and try to get caught up. But segment AC, in this case, we're adding some algebra here. So we have the same theorem, right? The midsegment is half as big as the segment that's parallel to it. And just plug in. This time segment LN is x plus 7. Segment AC is 4x plus 10. And notice I put 4x plus 10 in parentheses because we have to distribute this 1/2. 1/2 goes into both terms, so we get 2x plus 5. So x plus 7 equals 2x plus 5. I'm going to subtract x from both sides. Give me x plus 5 is equal to 7. And I'm just going to subtract 5 from both sides, giving me x equals 2. X equals 2. And it's always a good idea to check that. If we plug this in, the segment is 9 units long, 2 plus 7. And if we plug this, it better be 18. Let's see, 4 times 2 is 8, plus 10 is 18. So that checks out nicely. Number 4. We're going to put 8x plus 12 down here. And we're going to put 2x plus 18 up here. So we go, let's see, midsegment is equal to 1/2 times the length of segment AC. So same deal, just plug them in. making sure to put AC in parentheses. So 2x plus 18 is equal to, distribute here, we get 4x plus 6. I'll go a little bit faster when I solve this time. We get, let's see, 18 is 2x plus 6, so x is 6. It's not asking for x though, it's asking for the length of segment ln, so plug that back in, pretty simple. 2 times 6 plus 18, that's 12, and 18, that's 30. Let's check to make sure this is 60. 8 times 6 is 48, 48 plus 12 is 60, that fits nicely. Number 5. Pause it, give it a shot. You've seen enough now, I think you probably get the gist of this thing. Midsegment's half as big as AC, so plug them in. This time we have some sort of crazier algebra because we're not dealing with a segment AC that has even terms, which is fine. We can, we can solve this. 7 over 2x plus 2. You could have also cleared everything out by multiplying by 2. That's fine too. That's fine as well. But I'm just going to solve this thing. I'm going to subtract 3x from both sides. So when you take 7 over 2, which is 3.5, minus 3, well, that's just a half. This simplifies to 0.5x. And that's equal to 8. Subtract 2 from both sides, so we get 1/2 x equals 6. So 1/2 times 12 equals 6. Plug that back in, we'll see if everything fits together. So 7 times 12 is 84, so this should be 88. Let's check to make sure this is, 44. So 3 times 12 is 36, plus 8 is 44, so it fits together. Alright, here we have 3 midsegments drawn. So let's plug in some stuff, see if we can figure this out. So this distance right here, AO, is 7. OC, well, that's easy, that's 7 as well. You can tell by those 3 tick marks. So that's 7. If the whole thing is 14, then this, which is the midsegment that's parallel to AC, that has to be half as big as AC, which is, of course, 7. So ln is 7 as well. Segment AC is 14. So there you go. A little bit complicated looking diagram, but not too tough once you plug in this stuff. Number 7. Segment LO is right here. That's 11 units. And I need to know segment BN. Well, again, think about this, right? This is the midsegment, and it sort of corresponds with this segment right there. So this is pretty easy if you think about it, right? The midsegment is half as big as the side that's parallel to it. So we have 11, 11, and 22. All right, and if this is kind of confusing to you, what I suggest all my students do when they encounter really confusing diagrams is see if you can just draw the stuff that you need. So just draw, in this case, the midsegment that you need. These other ones are sort of extraneous here. They're kind of meant to be a little bit confusing. So this is 11, this is 11, and this is 22. 11, 11, and then 22. One more. Number 8. We've got, let's see, segment BA is 6.24. So right away I know this is a midpoint. So this is, let's see, 3.12, 3.12. Just cut that whole length in half. So this has to be 3.12 as well. And they're asking me for segment BL, got it. Segment AL, got it. And segment ON, got it. Using the triangle midsegment theorem. So I hope that video helped you. It was under 10 minutes. In the next one, we're going to go through, some geometric mean altitude theorem stuff, and we'll continue our study of triangles. So thanks for watching, and make sure you subscribe.